Good evening to all of you. Good morning to everybody. Welcome you guys. Welcome you all. I think we are live. Mm. So I think we are live. First of all, do check करके बोलिए ना is the audio video is clear to everybody. चेक करके कमेंट करके बोलिए ना. Right. So चलो. So let's start our discussion. So first of all, so great news from Unacademy. So these are the ESC 2025 rankers from Unacademy. You can have a look at. ESC 2025 rankers from Unacademy. So the test series which is live for GATE and ESC के लिए. So this year we have planned greatly so that you can utilize them properly. And so from December 15th onwards, the test series is which is available for already for the upcoming 2026-2027 के लिए भी. And we are starting the new batches for the 2027 के लिए नया batch शुरू हुआ. You can have a look at now from 29th January से नया batch. And so here and another batch is also started. So this is for 2028 के लिए भी. And this is for both EC and electrical दोनों के लिए. And the other top educators of Unacademy you can have a look at. And so Unacademy starters kit which is available in the all the Unacademy stores. If you want, you can get them by visiting the Unacademy store. And this is the Unacademy West Bengal Electricity Department का vacancies has been released. So इसीलिए हमने नया batch भी हमने शुरू किया. This is Asha Batch. Officers call and this crash course which is live. And another great feature of Unacademy is Unacademy Una, that is Unacademy AI tool. So there are three modes are there. One is voice mode, quiz mode, and smart summaries. And utilize these three modes so that will help you a lot. Especially the smart summaries, if we upload any of your file, it will summarize complete data will summarize it so that you can that will be helpful during the exam. And the test series are live, so you can see now test series for 2025 April 1st onwards which is live. And we do offer the two subscriptions. You can have a look at now here plus wala as well as the iconic wala. And plus में आपको क्या चीज मिलेगा? The top educators classes मिलेगा, live doubt solving, evaluated mains test series and structured courses PDF live quiz. इसके साथ unlimited access. You can watch the courses any number of times. And पर्सनल कोच भी अवेलेबल इन आइकॉनिक में एंड फिजिकल नोट्स भी प्रोवाइड करेगा. एंड द mentorship program is also available. You can book your slot according to your time convenience and you can utilize it. You can start the serious preparation with the Unacademy. Let's crack it. So चलो आज का सेशन हम शुरू करेगा दिस इलेक्ट्रोमैग्नेटिक्स में. इलेक्ट्रोमैग्नेटिक्स अभी इसमें इस कोर्स में हम क्या डिस्कस करने वाले, यू कैन हैव अ लुक एट नाउ. इन दिस कोर्स वी विल डिस्कस अबाउट द इलेक्ट्रोमैग्नेटिक वेव्स, ट्रांसमिशन लाइंस, वेव गाइड्स and antennas. There are 4 topics we are going to discuss. Right? Chalo. And before this, and we'll summarize the Maxwell's equation what we got in the previous course. We'll summarize them all the Maxwell's equations. Thereafter, we'll enter into these topics. This electromagnetic waves are originated from the Maxwell's equations, right? So इसीलिए हमने पहले Maxwell's equation briefly revise करेगा. Maxwell's equation. The first Maxwell's equation which came from the Gauss law. Gauss law. And what is Gauss law? According to Gauss law, the net electric flux leaving through any closed surface which is equal to 𝐂𝐤𝐿. Net flux equal to 𝐂𝐤𝐿. And from this we can conclude this as this flux which is equal to this closed surface integral of d bar dot ds, and which is equal to 𝐂𝐿, and that is equal to what? Tell me now. Volume integration of rho v into dv. And by equating the second term and the fourth term, so we can conclude this as equations will becomes as what? Tell me. By applying a divergence theorem. So this equations d bar dot ds, which is equal to what? Tell me. Volume integral of rho v into dv. Apply the divergence theorem. This is volume integration of del dot d into dv, which is equal to volume integral of rho v into dv. So from this we can write the equations as what? Tell me now. Del dot d, which is equal to rho v, and this is a Maxwell's first equation. This is a Maxwell's first equation. Next one. So this another equation. And this another equation of electric fields which came from the Faraday's law. The Faraday's law. And Faraday's law, according to Faraday's law, the induced EMF in any closed conducting loop, which is equal to what? Tell me. Induced EMF. Induced EMF in any closed conducting loop, that is closed line integral of E bar dot dl, which is equal to what? Tell me. The time rate of change of magnetic flux, that is d phi by dt. And this equation which we have modified as the EMF in a closed loop, that is closed line integral of E bar dot dl, which is equal to what? Tell me. Minus d by dt of what we can say flux is equal to surface integral of b bar dot ds. Now, so from this, which we can write it as, what tell me, closed line integral of E bar dot dl, which is equal to what we can say now, this is open surface integral of minus dou b by dou t dot ds, dou b by dou t dot ds. Now we have left side, we are applying a closed line integral, we are applying a Stokes theorem. By applying a Stokes theorem, so it will be converted to closed line integral is converted to open surface integral of what we can say now, this is del cross E dot ds, which is equal to what tell me now, open surface integral of minus dou b by dou t dot ds. Okay, now this left and right we have same open surface integral, so I can equate the corresponding components now. Here from this I can write the equation as what will be now, del cross E, which is equal to minus dou b by dou t, del cross E, which is equal to minus dou b by dou t. This is the second Maxwell's equation. Right? Next one. And the third Maxwell's equation, which came from the amperes. Third Maxwell's equation, which is from the Ampere's law. According to this Ampere's, the closed line integral of H magnetic field around any closed path, which is equal to I enclosed, that is current enclosed. And so this I enclosed is given as, we have two types of currents. One is a conduction current, other one is a displacement current. So that is surface integral of the conduction current and the displacement current dot ds. The two types of currents, conduction current as well as a displacement current, J plus dou d by dou t dot ds. Right. And by applying a Stokes theorem for the left side, closed line integral is converted to a open surface integral, that is del cross H dot ds, and which is equal to what will get, tell me, open surface integral of, that is J plus dou d by dou t dot ds. And we'll equate the components now. From this, which we can say this as del cross H, which is equal to what tell me now, J plus dou d by dou t, J plus dou d by dou t, and so this is the Maxwell's third equation, third Maxwell's equations. Next, the fourth Maxwell's equation, which is, I can say this as a Gauss law for magnetic fields. Previously, what we have seen, we can say this as Gauss law for electric field. Now we talking about the Gauss law for magnetic fields. That is Gauss law for magnetic fields, and which is given as this is closed surface integral of V bar dot ds, which is equal to 0. Closed surface integral of B bar dot ds equal to 0. And here also we can apply this divergence theorem. Then this is volume integral of del dot B into dV, which is equal to 0. From this we can say this as del dot B, which is equal to how much? Del dot B, which is equal to 0. Right, this is the fourth Maxwell's equation, and this equation will signifies that magnetic monopoles does not exist. Magnetic lines are always in a closed form. Magnetic lines are always in a closed form. Right. Now you can see this thing here. These are the four Maxwell's equation we have seen. Now look at the equation now, the fourth Maxwell's equation. This is del dot B equal to 0. Del dot B, the divergence of a vector is 0, then that vector is called it as what element of solenoidal. Then that vector is called it as a solenoidal. So that means magnetic field is a solenoidal. And we know the relation for the any vector quantity. For any vector, it has to satisfy the condition. What the condition has to satisfy? So the divergence of curl of any vector must be equal to 0. The divergence of curl of any vector must be equal to 0. By comparing those two equations, we can conclude it as what? Tell me now. That is B is equal to what? Tell me. Del cross A. B equal to what? Tell me. Del cross C. What the B is the? Here B, which is the magnetic. Here B is what? Tell me. Magnetic flux density. B is the magnetic flux density. And what about this? A is a magnetic vector potential. A is called it as a magnetic vector potential. Simply call it as a potential. So this A is a magnetic vector potential. Okay. Right. Next, and we already seen this thing as what element of del cross B. What the del cross B is, tell me now here, which is equal to minus of dou B by dou T. Right. So here you can see now del cross E, and which is equal to minus of dou by dou T of B. What the B is equal to what element of del cross A? B is equal to del cross A. Right. So from this, what I can say now here, this is del cross of E, which is equal to minus del cross of what we can say, tell me now, dou E by dou T. Del to this side, then it will becomes del cross of what? Tell me now. That is E plus dou E by dou T, which is equal to 0. Now you see this thing, the curl of a vector is 0. If the curl of a vector is 0, then that vector is called as a irrotational. Here this is called as, what, tell me? Irrotational. This is called as a irrotational vector. So you can see now here, if it is irrotational vector, as we know, for any vector we know the relation. For any vector quantity, the relation is, what will be now? The curl of gradient of any scalar quantity, which is equal to 0. By comparison of these two equations, we can conclude it as, what, tell me? That is E plus dou A by dou T, E plus dou A by dou T, which is equal to minus del V without loss of generality will continue. E plus dou A by dou T equal to minus del V. And from this, what is this? E is equal to, what, tell me? Which is equal to minus del V minus dou A by dou T. Okay. Minus del V minus dou A by dou T. Here, what is this? V is called it as a, where this V is called it as a, so is called as a electric scalar potential. Is called as a electric scalar potential. A is called as a magnetic vector potential. And this is the relationship between the vector potential and the scalar potential. Right, all of you? Relation between the vector and scalar potential we have seen. Next. So if we have summarized all the things, you can see now the Maxwell's equations. Look at now summary. If we have considered the Maxwell's equations, the here what we are applications we are going to discuss. The first one is del dot D, which is equal to rho V, and del cross E equal to minus dou B by dou T. Next, and del cross H, which is equal to J plus dou D by dou T. Del dot B, which is equal to 0. In addition to that, so you need to remember the things as, in addition to that, we should remember the things as, what, tell me? D is equal to epsilon E, and B is equal to mu H, and J equal to sigma E. These equations you have to remember. Okay. Done. And apart from this, we have a boundary conditions also now. And what the boundary conditions tell me? The boundary conditions are, the boundary conditions, first boundary conditions is E1t, which is equal to E2t. And the second boundary conditions, d2n minus d1n, which is equal to rho s. And the third one, h2t minus h1t, which is equal to k cross an. And the fourth one, that is d2n equal to d1n. These are the boundary conditions we need to use. Done? Now let's talk about the time harmonic form. What is a time harmonic form? So of course you may also call this as a phasor form. The time harmonic form, which is also called as a phasor form. So in case of a time harmonic form, the things what we need to do here, if we have some vector is there, the time harmonic form of vector is vector itself. Okay, vector only. If there is a differentiation, if we have dA by dt, the time harmonic form of derivative, which is equal to what, tell me? We need to multiply with j omega into a. If there is a derivative is there, we should multiply with a j omega, similar to like a Fourier transform. And if we have a 2 times differentiation, our derivative is only with the time only, not with the space. D square a by dt square, then will come it as what, tell me now? J omega into j omega whole and into a. So we should multiply with j omega again. And if we have the integration is there, so obviously what we need to do, tell me now? If there is integration is there, what we need to do here? We need to divide with j omega. Integration is there, we need to divide with j omega. Right. Done? Now let's talk about this electromagnetic waves. Electromagnetic waves. The electromagnetic waves. Maxwell is the first person who predicted the existence of the electromagnetic waves. Maxwell is the first person who predicted the existence of the electromagnetic waves, but this Maxwell, he is unable to generate the electromagnetic waves. Maxwell's unable to generate electromagnetic waves. Later, another scientist, Professor Hodge, successfully generated and detected the electromagnetic waves. That's a reason these electromagnetic waves, we can also call them as what, tell me now? Hertzian waves. Electromagnetic waves is also called as a Hertzian waves. And the electromagnetic waves should satisfy all the 4 Maxwell's equations. All the 4 Maxwell's equations everywhere. It has to satisfy all the 4 Maxwell's equations at the transmitter, has to satisfy receiver as well as throughout the channel also the 4 Maxwell's equation to satisfy करना. ठीक है? चलो. Next. Now before discussing the Maxwell wave equations, we'll discuss about different type of mediums. So what are the different type of mediums now? any medium was classified based upon the three parameters. Those are called as a medium parameters. That is mu, and the other one is epsilon, the other one is sigma. These are called as what? Tell me now. These are called as a medium parameters. These are called as a medium parameters. And these are also called as a primary constants of medium. Primary constants. These are also called as a primary constants of medium. The properties of any medium will depend upon these parameters, right? And these parameters, which we can also call as a constitutive parameters. Constitutive parameters. And the relations what we have seen here, B is equal to mu H, and then D is equal to epsilon E, and J is equal to sigma E. And these are called as a constitutive relations. Constitutive. Okay, these are called as a medium parameters. Primary constants of medium, also called as a constitutive parameters. The properties of any medium will depend upon these three. Now let's talk about different type of mediums. And we'll talk about the first one is a linear medium. Linear medium means what? The medium parameters are independent of magnitude of electric and magnetic fields. If it is independent of magnitude of electric and magnetic field, that mediums are called as a linear medium. Next, homogeneous medium. If the homogeneous, the name itself indicates same. If it is homogeneous, then only we can call it as a same everywhere. Then we can call it as a homogeneous. Otherwise, inhomogeneous. So that means homogeneous means the medium parameters, what we have seen, mu, epsilon, sigma, these are independent of space. These parameters must be independent of space, means point to point does not change. Independent of space. Should right. Isotropic means, so those parameters must be a constant. Those parameters must be a constant, should not be a complex quantities, only should be real constant. So means if we have taken epsilon is given as something 2 epsilon naught, and let us say mu is given as, let us say 3 mu naught, then we can call this medium, this is called as an isotropic medium. This is isotropic medium. And for example, if we have, let us say this epsilon, which is equal to of the form, this is epsilon dash minus j epsilon double dash. If we have like this form, it has a real as well as a imaginary term. And similarly, mu is given as, we can say this as mu dash minus j mu double dash. If we have like this, then these type of mediums are called as an anisotropic medium. These are called as an anisotropic medium. Right. Right. Next, charge-free medium. Charge-free, the name itself indicate we don't have any type of charges in the corresponding medium, that is called a charge-free medium. Means all type of charges must be zero. Right. So that means we call the line charge density and surface charge density and volume charge density. All type of charges must be zero. Next, non-conducting medium. Non-conductor means it should be a dielectric only. Dielectric means what, tell me now? So this is non-conducting medium means the medium must be a dielectric. Dielectric medium means sigma value. How much the sigma value, tell me? Sigma equal to 0. Dielectric medium sigma value equal to 0. Sigma. And so this is surface current density K is also equal to 0 for in case of a non-conducting medium. Right. Next, unbounded medium. Unbounded medium means what? There is no restrictions. If there is no restriction, the wave can able to propagate any direction, any distance, then we can call that as an unbounded medium. So if we have considered this as a electromagnetic waves which will enter, they will keep on can travel any distance anywhere, no restriction for it. That is the type of mediums are called as an unbounded medium. So here, and if we talk about this as a examples of bounded mediums. What are examples of bounded mediums? Transmission lines. Transmission lines, the wave has to travel only through the wires only now. And what else you can see now? Waveguides. Waveguides also, wave has to travel only inside the waveguide only. And like we can say this has all transmission lines and optical fibers also. Optical fibers also, it is those also comes under unbounded mediums. Unbounded medium example, that is the only medium that is unbounded is free space. Free space is the only medium that is unbounded. Okay. Free space is the only medium which is linear, homogeneous, isotropic, charge-free, non-conducting, unbounded medium. Free space is the only medium which is satisfy all the ideal properties, homogeneous, isotropic, charge-free, non-conducting, and unbounded medium. There is no physical medium can be other than the free space. For the free space, the properties of mediums are epsilon equal to, that is epsilon naught, and that is mu equal to mu naught, and sigma value is how much? 0, and rho v, volume charge density, which is also equal to 0. surface current density, which is also equal to 0 for in case of a unbounded medium, that is free space. Right? Now let's talk about the general wave equations. So we are considering we have one medium, that medium which is linear, homogeneous, isotropic, charge-free, unbounded medium. Let's talk about this medium. So what are the Maxwell's equations? You tell me now. First equation, which is equal to del dot D, which is equal to what? Tell me now. Rho V. And how this medium, you see this thing here? Medium is a, what type of medium is a? Charge free. Charge free medium means what is rho V value? Tell me now. Rho V value will become 0. Right. So from this, what I can say now, from this equation, I will write this as del dot D, which is equal to 0. Now, as we know, D is equal to epsilon E now. D is equal to, the medium is homogeneous we have taken. From this we can write it as del dot E, which is equal to 0 I can write. Let us call this is one equation. And what is the other equation we have? Del cross E, which is equal to what? Tell me now. Minus of dou B by dou T. And which is equal to, B is equal to mu H, that is minus mu naught. Let us say mu only, mu into dou H by dou T. B is equal to mu H. And let us call this as a second equation. And what about third equation? Del cross H. Del cross H, which is equal to what? Tell me now. That is J plus dou D by dou T. Right. So this is del cross H, and which is equal to J. J equal to, J we are writing here, J plus D is equal to epsilon E, then epsilon into dou E by dou T. And call it as a third equation. And what is the fourth equation we have? Del dot B, which is equal to 0. B is equal to mu H, so that's why del dot H will becomes what? Tell me now. 0, and call it as a fourth equations. Okay, we have got these 4 equations now. Right. The 4 equations we have seen. Now, from this we'll develop the Maxwell's equation. What the first equation we have, you see? And we have taken the second equation. And take the second equation. And apply the curl on both sides for second equation. So that is del cross E, which is equal to minus mu into dou H by dou T. Now apply the curl on both sides. That is what I mean of del cross E. Curl on both sides, which is equal to minus mu into dou by dou T of what? Tell me now. Del cross H. Take the curl on both sides. Now expand this del cross E. So this is del of del dot E minus what? Tell me now. Del square E, and which is equal to minus mu into dou by dou t of del cross H. From third equation, del cross H is equal to, yes, what we have, tell me now, J plus what, tell me now here, epsilon into dou E by dou T, epsilon into dou E by dou T. From the equation 1, del dot E, which is equal to 0 na, then we'll come it as minus del square E minus mu into, so this is what we have, that is dou by dou t of J is equal to what, I know, sigma E na, plus epsilon into dou E by dou t. So you can simplify this thing, minus will get cancelled. So that is del cross E, which is equal to what, tell me now here, this is mu sigma into dou E by dou t plus what, tell me now here, mu epsilon into dou square E by dou t square. So we'll get the equation like this now, you see, del cross E, which is equal to mu sigma plus mu sigma dou E by dou t plus mu epsilon into dou square E by dou t square. And this is the electromagnetic wave equation in terms of electric field. And the same thing we can develop from the other equation. So that is, we have seen third equation. We are taking a third equation we have taken, and what third equation, you tell me? That is del cross H, del cross H, which is equal to what, tell me? Del cross H, which is equal to, we have seen from the third equation, J plus this much na, we are using this equation, that is J plus epsilon into dou E by dou t, where J is equal to sigma E. So that is del cross H, which is given as what, tell me now, sigma E plus what, tell me now here, epsilon into, that is dou E by dou t. Now I'll take the curl on both sides. Now when you have taken a curl on both sides, del cross H, so will come to be a what, tell me now here, sigma into del cross E, okay, plus epsilon into dou by dou t of what, tell me now, again curl del cross E. So expand this thing here. This is del of del dot H minus what, tell me now, del square H, which is equal to sigma into, and del cross E from the second equation, minus mu dou H by dou t, that is minus mu sigma into what, tell me now here, dou H by dou t, and minus mu epsilon into, that is dou square H by dou t square. Okay, now you can see now here this one, right, this term which is equal to 0, del dot H is equal to, from fourth equations. Now you tell me now, that is minus del square H, which is equal to minus mu sigma dou H by dou T minus mu epsilon dou square H by dou T square. Okay. So you can cancel this minus sign on both sides. We cancel the negative sign on both sides. Now you tell me now what will come here. Then will come it as del square H. Del square H, which is equal to mu sigma into dou H by dou T plus what will be now mu epsilon into dou square H by dou T square. This is the another equation of electromagnetic wave in terms of magnetic field. And previously we have seen in terms of electric field we have seen na? So we'll call this as equation 5 if I say, and this is equation number 6, where this equation 5 and 6 are called as electromagnetic wave equations. So this equation, both equations similar to each other if you observe. So finally the equations what we got in terms of electric field, that is del square E, which is equal to what, tell me, mu sigma into dou E by dou T plus mu epsilon into dou square E by dou T square. Next, the other equation is what, tell me, del square H, which is equal to what, tell me now, mu sigma into dou H by dou T plus mu epsilon into dou square H by dou T square. These are the electromagnetic wave equations in terms of electric and the magnetic fields. Right. Try to remember these equations. Right. Now here we are using the concept called as a time harmonic form. Time harmonic form means what, tell me now, whenever there is a time derivatives are there, we need to multiply with a j omega. So tell me now first equation, time harmonic analysis we can say. Time harmonic form, that is what, tell me now here, del square E, which is equal to, this is mu sigma into, so we have a time derivative, so we should multiply with a j omega into E plus what, tell me, so this is mu epsilon into what I can say now, 2 time differentiation, we should multiply j omega into j omega. So that is j omega square na into what, tell me now, E. Got this thing, tell me? So from this, which we can say this as what, tell me now, del square E, and which is equal to, I am taking it as a, so here j omega mu I am taking common, j omega mu I am taking common, then what is left out, you tell me here. J omega mu, this is what is sigma, plus here we have one j omega is left out, not j omega epsilon into E. Check this thing all of you. Right, this whole term we have taken as some constants. I am writing it as del square E, which is equal to, this is gamma square E. This way writing it as del square E equal to gamma square E. Okay. Next. Where this gamma square is, this whole term we have taken as gamma square. Similarly, you can try for this one second equation. For this equation also we do the same thing. Tell me what we have. Tell me now here time harmonic form del square H, and which is equal to what? Tell me now here. This is mu sigma into what I can say. Tell me now J omega H plus what? Tell me now here. This is mu epsilon into what I can say. Tell me J omega into J omega square into H. Now you can tell me now what I will get. Del square H, and which is equal to what? Tell me J omega mu. I am taken common. Then here will come it as sigma plus J omega epsilon into H will come now. So this also it should be taken as del square H. The whole term I am taking it as gamma square into H. Okay. So you can see the way this gamma square is what we have taken this term. So this gamma which is equal to square root of J omega mu into sigma plus J omega epsilon. Okay, these are the electromagnetic wave equations. Now let us call this as equation numbers. We have 5, 6. Now this is 7, 8. 7, 8. This 7, 8. These are called as a electromagnetic wave equations in time harmonic form, and which we can also call it as, these equations are called as a Helmholtz equations. Heard these words? These are called as a Helmholtz equations. Right? Chalo. Now let's talk about the waves, that is uniform plane wave. Uniform plane wave. So our entire discussion is about the uniform plane wave only. So all of you listen very carefully. And uniform plane wave is an electromagnetic wave. Yes, is an electromagnetic wave in which both electric and magnetic fields are directed in a fixed direction. Its amplitude and phases are constants over the plane normal to the direction of propagation of wave. So these are nothing but, so these are the electromagnetic waves, and these are the waves which are electric and magnetic fields are directed in a fixed direction, and the amplitude and phases are constant, where in the normal plane these are constants. Let us consider we have and let us consider this wave. I am considering this as a x-axis, this as a y-axis, this is the z-axis, and assume that the electromagnetic wave which is propagating along the z direction like this. Consider the electromagnetic wave is propagating along the z directions. So this wave, the wave propagation will indicate it as k. And this k is what direction we can say now? This is AZ cap along the z directions. Now what they're saying here, amplitudes and phases. Whose amplitude and phases? Electric field amplitude and electric field phase, and magnetic field amplitude, magnetic field phases are what? Tell me now. Constant. Where they are constant? In the normal plane. If we see here, this they are saying this electric field is what? Tell me. Electric field is a constant. Where they are constant, you tell me? In the normal plane. So the wave is propagating z direction, which is a normal plane here. The normal plane, which is equal to what I can say? Tell me now. XY plane. Normal plane is what? Tell me now. XY plane is a normal plane. And the magnetic field is also constant. Which plane the magnetic field is constant? You see, magnetic field is constant in the which plane? You can see now here, XY plane. XY plane, normal plane, electric field, magnetic fields, amplitude and phases are constants. And so you can see now, if it is a constant, so then the derivatives will become what? Tell me now. Dou E by dou X will becomes what? Tell me now. 0. Right. And dou E by dou Y with Y direction also constant only now. 0. And magnetic field is also constant only. Dou H by dou X is 0. And dou H by dou Y, which is also 0. Okay. Right. So if you observe carefully, now you see this thing. If the dou E by dou X is 0, what the dou D by dou X? Also 0. Now D is equal to epsilon E. Okay. So what we can say now here? Dou B by dou X also 0. Dou B by dou Y also 0. So from this, what we can conclude? You tell me now here. What we can conclude now here? From this, what we can conclude now? This property is, if the electromagnetic wave is propagating along the z direction, if this electromagnetic wave which is propagating along the z direction, then what happens? You see this thing here and these terms, and what happens now here? That is dou by dou X of what? Tell me now. Whether you take it as E, or you may take it as a D, or you take it as a H, or you take it as a B. So what happened? You tell me now. Those derivatives are what? Tell me now. Zeros. Okay. And dou by dou Y of what? Tell me now here. E, D, H, or B. And all the things will become 0 only now. Right. So from this, what we can say now here? That is, if you take either D, you take E, we take H or B, anything it is 0 now. So from this, we can conclude this as what? Tell me now here. Dou by dou X. Dou by dou X, which is equal to what? Tell me now. 0. Dou by dou Y, which is equal to 0. Dou by dou X, dou by dou y, which is equal to 0. All of you, either you take E, D, H, B, anything. So anything it will be 0 only. Okay. Here we have taken the wave is propagating what direction now here? We have taken Z direction. That's why dou by dou x, dou by dou y's are 0. Okay, if it is some other direction, correspondingly will change it. Okay. Done. Now, here, and the second point is, if the wave is propagating Z directions, if the wave is propagating Z direction, then the component of electric field along the Z direction is 0. Component of magnetic field along the Z direction is 0. Electric and magnetic fields does not have any components along the Z directions. Okay. Electric and magnetic fields does not have any components along the Z directions. All of you, if the wave is propagating Z direction, component of electric field, component of magnetic field along the direction of propagation is 0. Fine? Next. And this electric field, magnetic field, direction of propagation of waves are orthogonal, orthonormal and follows right-handed system. Means what, tell me now here? This electric field, angle between electric field, magnetic field and direction of propagation of wave are what, tell me? Orthogonal, orthonormal and follows right-handed system. E, H, K, these are orthogonal, orthonormal and follows right-handed system. The angle between them is how much? 90 degrees. And if you do this as a, that is E bar cross H bar, then you will get it as what element of K direction will come. And if you do this as a H cap cross K cap, then you will get the direction of electric field will come. And then this is K cross E cap. Then we'll get it as a magnetic field direction will come. So that means what we can say, this is the order you need to remember, like I, J, K. E, H and K. This electric field, magnetic field and direction of propagation of wave will form a orthogonal, orthonormal and right-handed system. This is positive. अगर ऐसा move किया तो. So these are the three properties of the plane waves. If when we are talking about the plane waves now, so any plane wave has to satisfy these three properties, right? Now finally we can conclude this as what, tell me now here? For the uniform plane wave, that is UPW, uniform plane wave, if the wave is propagating along the Z directions, generally will consider wave propagate along the Z directions unless not mentioned. If the wave propagate along the Z direction, AZ cap, the properties has to satisfy is what, tell me now? The first property is what? That is dou by dou x and dou by dou y, which is equal to 0. And the second property is the component of electric field and the component of magnetic field along the propagation of wave, it is 0. And the next one is the electric field and magnetic field and direction of propagation of wave are orthogonal, orthonormal, and follows right-handed system. EHK will form a right-handed systems. Right? Next. Now we'll talk about the wave general solutions of wave equations. You see, yeah, you can try to answer this question. Which one are the following field pattern represent TEM wave means a uniform plane wave. Transverse electromagnetic wave means uniform plane wave traveling in the positive x direction. The wave is propagating what direction? Positive x direction has to do. Now check this option which will satisfy, and you can see the first option. We need to get the k direction means what? Tell me now here. E cross H na? E cross H. So that means here the k direction is what? E is what? Tell me now. AY. This AY cross minus AZ. So you can tell me now k what will come? Minus y cross z will come it as ax na. This is the negative x, so this is not the option. Next option B, tell me now here. And this k is what? Tell me now. E. This is minus AY cross what? Tell me now. Minus AZ. So that is k is what? Tell me now. Minus or minus plus only. Y cross z which is equal to ax only na. So the second option is correct. If you want, you can verify the remaining options also. Next one is k direction is what? Tell me now. E cross H, that is AZ cross AY na. AZ cross AY will come it as what? Tell me. Minus AX will come na. Next option D. K is what? Tell me now. AY. This is minus AY cross AZ, which is equal to what? Tell me now here. This is minus y cross z. So this is AX. So only this option will satisfy now. Next. Solution to the wave equations. Yes, the general solution for the electromagnetic wave equations is the general expression for electric field. You see this thing E, which is equal to so what we can say, this is now here, this is E naught into e power minus alpha z, E naught into e power minus alpha z into what? Tell me now here. Cos of omega t minus beta z into ax cap. Let us consider. So this is the general form of the electric field expression, where what is E naught is called it as a peak amplitude or maximum amplitude of electric field. This is called it as what? Tell me. Maximum electric field. And so, and this AX cap, this is called it as a direction of electric field. Direction of electric field. C is the direction of electric field. And here this alpha, which is called it as the attenuation constant. Alpha is called it as a attenuation constant. And this omega, which is called it as a angular frequency. Omega is called it as a angular frequency. And with beta, which is called it as a phase constant. Beta is called as a phase constant. And the Z is called it as a, this will indicate the direction of propagation of wave. Direction of propagation of wave. And if it is minus Z, means wave is propagating along positive Z direction. If it is a plus Z, negative Z directions. Right? So these terms you try to remember, these parameters. Now let us talk about these parameters, these relations we are going to see. अभी इसका relations हम देखेगा. Right. Let us talk about one by one. The phase velocity. Phase velocity, the velocity with which the phase of the wave travels, that velocity is called as a phase velocity. The phase velocity, and which is given as, if I call this as a VP, which is given as omega by beta, omega by beta. Or we can simply, other form we can write it as, this is the ratio of coefficient of T by coefficient of T by coefficient of Z. Okay, coefficient of T by coefficient of Z. Next one, wavelength. Wavelength means what? Tell me. The distance between 2 points is said to be a wavelength if the phase difference between those 2 points equal to 2 pi, then we can call it as a wavelength. And the relation between the phase difference and path difference is, that is delta x by lambda, which is equal to delta phi by 2 pi. That is also equal to delta t by time period, where delta x is called as a path difference, delta phi is the phase difference. So what I can say now here, delta x by lambda, which is also equal to delta phi by 2 pi. This is a relation between the phase difference and the path difference. Phase difference and the path difference. That is the relation lambda, which is given as 2 pi by beta. Lambda is given as 2 pi by beta wavelength. Okay. Next, group velocity. Group velocity. Phase velocity is the velocity of the carrier signal. Group velocity is the velocity of the message signal. Velocity of message signal is called as a group velocity. That is Vg. The group velocity Vg, which is given as what are we now, d omega by d beta. Group velocity Vg equal to d omega by d beta. Right, if we have seen this thing as, we have seen Vp, phase velocity Vp, which is given as omega by beta. Omega by beta. Now I am differentiating the Vp with respect to omega. That is dVp by d omega. If I differentiate now, u by v rule we can apply here. Beta into d omega, so this is 1 minus omega into, this is d beta by d omega by beta square. So from this, which we can get it as dVp by d omega, which is equal to, we split it now here, this is beta by beta square minus omega by beta square into d beta by d omega. Now see what I'll get, you see this thing, dVp by d omega is equal to 1 by beta minus omega by beta. I can say omega by beta equal to Vp. So this we can say Vp by beta into, so this is dVp by d omega. Take the beta to this side, beta into dVp by d omega, which is equal to 1 minus, so this is, I can say this as Vp by Vg. So from this we need to get Vg na, so this is Vp by Vg, which is equal to 1 minus dVp by d omega. From this Vg, which is equal to what, tell me now? This is Vp by 1 minus, here beta also there na, beta. So this is beta into dVp by d omega. Okay. This. This is Vg. This is the relation between the phase velocity and the group velocity. Phase velocity and the group velocity. Next. Dispersion. Dispersion means what, tell me now? If the phase velocity depends upon the frequency, then this phenomenon is called as a dispersion. So dispersion. This phenomenon is called as a dispersion. We have the different type of dispersion. One is called it as a normal dispersion. Normal dispersion means as frequency increases and Vp value decreases. If the frequency increases, Vp decreases, then this phenomenon is called it as a normal dispersion. And for this, that means these are opposite now here. That means what happens to dVp by d omega? Since these are inversely, so this value which is equal to what, tell me now, negative. Now, so this means Vg which is equal to what the formula we have seen here, Vp by 1 minus beta into dVp by d omega na, dVp by d omega. So you see this thing, yeah, dVp by d omega is negative, minus or minus will become plus. Then as a result, which is greater, Vp greater or Vg greater here? Here we can say that Vg value will be less than Vp banega. Group velocity is less than phase velocity banega. Right. This phenomenon is called as a normal dispersion. And the next one is anomalous dispersion. Anomalous dispersion means what? As this omega increases, Vp also increases. This phenomenon is called as an anomalous dispersion. Then what is this thing? dVp by d omega. dVp by d omega. Both are increasing now, so that's why this value will become positive. And what is this Vg value? Tell me. Vg value, that is Vp by, so this is 1 minus beta into dVp by d omega. So you see this thing here, anomalous dispersion. So this is the dVp by d omega is positive, so it will be negative only now. As a result, what happens now here? Group velocity is greater than phase velocity. But practically it cannot happen. This is the abnormal situation. It never happen in practical scenario. Okay. The other thing is what we can say. So non-dispersive medium means Vp, the phase velocity, which is independent of what you see, this is independent of frequency. Independent of frequency. Now dVp by d omega. So find the dVp derivatives. We need to do it now. dVp by the rate of change of Vp with respect to omega we need to calculate. And it is independent of frequency. If it is independent of frequency, then what happens? You see this thing. Then dVp by d omega will becomes what? Tell me now. This derivative will become 0 now. If it is independent of frequency. Here in this case, so this is as omega frequency increases, Vp decreases. These are inversely proportional, so that's why will come the negative sign will come. Here it is what element both are increasing now, so positive, the value will become. The value we can see later, we are just observing here how the variations, which is greater Vp greater, Vg greater, we are seeing here in this case. Then what happens now, Vg, so that is Vg equal to, this is Vp by, tell me now, 1 minus beta into dVp by d omega. So that means what is the dVp by d omega value? So this value to 0 hai na. So that means what I will get, you see this thing, Vg is equal to Vp banega. That means group velocity and phase velocity both are equal. Then group velocity and phase velocity both will becomes equal na. And this phenomenon is called as what, tell me now, non-dispersive medium. In case of a non-dispersive medium, group velocity, phase velocities are equal. Okay, fine. Right. Okay, then that's it for today's session. And the next class will meet and will discuss the remaining topics. Okay, then see you. Bye bye.